So hello everyone, I'm Fel Angelica Liza Q. Udalbe. I will be the one who will discuss problem 5 and 6. It is all about balancing equation, finding the standard enthalpy and finding the standard entropy. So let's start answering number 5. So we are asked to balance each equation, predict the sign of standard entropy if possible, and calculate its value at 25 degrees Celsius. So this equation is not balanced yet. All we have to do is to balance it first. So we have to balance it first before na to pangitaan na to ang standard entropy. So ang balance equation niya is this. So we can observe that we just add 2 here so that our reactant will be balanced to our product. So we can observe that our sodium here is, we have 2 moles of sodium, and here we have 2 moles of sodium also, and 4 moles of oxygen, 4 moles of oxygen, and 2 moles of hydrogen and 2 moles of hydrogen, 1 mole of carbon and 1 mole of carbon. So next step is to find the formula for standard entropy. So the formula is this. We just input our product here, which is this, and our reactant here, which is this. So next step is, so we input it here, our product and our reactant. We can get its value through thermodynamics data at 25 degrees Celsius. So the value of sodium carbonate is 135.98 joules per Kelvin mole, and for water is 69.9 joules per Kelvin mole, and for sodium hydroxide we have 64.454 joules per Kelvin mole, and for carbon dioxide we have 213.6 joules per Kelvin mole. So next step is we multiply the value to the mole. So the answer is the same because it just have 1 mole, the same, and this we have 128.908 joules per Kelvin, and kani 213.6 joules per Kelvin. So add the product and add the reactant. The result will be 205.88 subtract to 342.508 joules per Kelvin. So the answer will be negative 136.628 joules per Kelvin. But we need to find the significant figure. So the final answer would be the standard entropy is equals to negative 136.6 joules
Let's
per
proceed
Kelvin.
to 5B. Same process we do in 5A. Ato Japon pangitahan yung balance equation. As we can observe, we just add 2 and 3 for it to be balanced to our product. We have 2 moles of iron, 2 moles of iron, 6 moles of hydrogen, 6 moles of hydrogen, 3 moles of oxygen, 3 moles of oxygen. Dayon, pangitaon din nato ang standard entropy. We just input our product here and our reactant. So same as 5A, we get the value from thermodynamics data at 25 degrees Celsius or 298 Kelvin. So we will just have to multiply it by the mole. So 90.0 joules per Kelvin, 393 joules per Kelvin. And subtract it to our reactant. 54.4 joules per Kelvin plus 566.1 joules per Kelvin. The result is 483 joules per Kelvin minus 620.5 joules per Kelvin. We will have negative 137.5 joules per Kelvin. And for the final result, we will have standard entropy equals negative 138 joules per Kelvin.